Hello, ladies and gentlemen. Welcome to Mr. Skinner Teaches Newton's Laws Using Games once again. This is a new game of mine called Jumpin Monkeys. Jumpin Monkeys. Why is it called Jumpin Monkeys? It's got a tree here. We've got these little monkeys and our springboards. And here is why it's called Jumpin. Oh, knocked that one out. Hey, this is why it's called Jumpin Monkeys, because we're launching our monkeys into the tree using our springboards. And so this makes it kind of fun and entertaining. Probably going to cause a bit of a mess in class. I'm looking forward to seeing how that works, trying to get them to stay in place. So how does this game demonstrate Newton's 3 laws of motion? Well, it's actually a really, really ingenious game. First off, we've got Newton's first law of motion. Object at rest stays at rest unless acted upon by an outside force. Well, we've got some monkeys at rest in the tree, and they will stay at rest unless one of these other monkeys comes and hits them, or I grab them with my fingers. So that would be the outside force, but they're objects at rest and they're staying at rest. In fact, these ones here on the table are objects at rest, and they'll continue to stay at rest until acted upon by an outside unbalanced force. That unbalanced force is actually the spring mechanism here in our launcher. It's got an elastic force that, when compressed, allows it to push back and causes them to launch upwards. That force right there is the unbalanced force that causes the objects to go from being at rest to being in motion. Now, it also demonstrates the other half of Newton's first law: an object in motion stays in motion. Once these monkeys start to move, they can fly a long, long way. They're going to continue moving until gravity starts to pull them back, or they hit the tree, which is kind of a resistance force. So they're going to stay in motion until acted upon. That object is now going to stay at rest until it's acted upon, probably by another one of the monkeys. But the object in motion stayed in motion until it hit something, until gravity caused it to act. Now, Newton's second law also states that it takes a force to accelerate a mass. We can see that right here. When there's no elastic force and no muscular force storing that elastic force, the object's not going to move. But once the force acts on the mass, it causes that mass to accelerate quite quickly, and it launches upwards. That acceleration is really fast, even with this tiny little force, and they're launching all over the place. You also notice that the force of gravity accelerates them back downwards. We see that as it goes. My favorite part about this game, oops, knocking my monkeys around, is Newton's third law of motion. For every force, there's an equal and opposite force. And it's demonstrated in a couple of really, really ingenious ways. For every force, if I push downwards on this, I can actually feel the springboard pushing against me. So for every force downwards, there's an upwards resistance force. And when I remove that force, I can see that force get applied. So for the downward force creates an upward force. When it's released, that upward force pushes it upwards. Now, it's also pretty obvious as the monkeys fly through the air. For every upward force, as the object is moving upwards through its inertia, part of Newton's first law, hey, there's a downward force pulling it back down. And that's what's actually going to cause it to slow down and change its motion. Hey, and we have the monkeys. Okay, so for every force, there's an equal and opposite force, demonstrated by Newton's third law of motion. We saw Newton's first law in action, and objects were at rest. They're acted upon by an outside monkey, causes them to move. So this is Newton's third law of motion, Newton's second law, Newton's first law, all right here in a cute little kids game. It makes a lot of noise and probably going to make a bit of a mess in class. Looking forward to seeing how that goes. Wait until next time, and we'll be learning more about Newton's laws and some of my weird games. Jumpin' Monkeys, Newton's laws.